A frozen world. Imagining Snowball Earth. Imagine our Earth, not as we know it, but as a giant snowball. This is not a scene from a science fiction film, but a scientific theory known as Snowball Earth. Picture this: continents buried under miles-thick ice, glaciers stretching down to the equator, and oceans frozen solid. This was our planet's reality millions of years ago. The average temperature plummeted to a frigid -50 degrees Celsius. Life as we know it hung by a thread. But how did our planet transform into this frozen wasteland? Let's delve deeper into this fascinating chapter of Earth's history. Clues from the past. Unveiling Earth's icy secret. The Snowball Earth theory didn't appear overnight. It emerged from geological detective work, piecing together evidence scattered across the globe. Scientists studying ancient rocks found something peculiar. They discovered glacial deposits, remnants of ancient ice sheets, in places that are now warm, like Australia and Namibia. These findings suggested that ice once covered these regions, hinting at a much colder period in Earth's past. Further investigations revealed that these glacial deposits were remarkably widespread, found on almost every continent. This discovery was a major clue, suggesting a global ice age of unprecedented scale. The perfect storm forces behind the Big Freeze. So, what triggered this extreme ice age? The answer lies in a complex interplay of factors. One key player was continental drift. As continents shifted towards the equator, they reflected more sunlight back into space, reducing Earth's overall temperature. Volcanic activity also played a role, releasing massive amounts of ash and aerosols into the atmosphere. These particles blocked sunlight, further cooling the planet. This led to a runaway cooling effect. As ice sheets expanded, they reflected more sunlight, causing further cooling and ice growth. This cycle continued, eventually engulfing the entire planet in ice. Echoes in stone evidence of a frozen planet. The evidence for Snowball Earth goes beyond just glacial deposits. Scientists have found other telltale signs in ancient rocks. One such piece of evidence lies in the chemical composition of these rocks, specifically the levels of carbon dioxide. During Snowball Earth, carbon dioxide levels in the atmosphere plummeted. This is because the planet's natural carbon cycle, the process by which carbon dioxide is exchanged between the atmosphere, oceans, and rocks, was disrupted by the ice. This drop in carbon dioxide, a potent greenhouse gas, further accelerated the cooling, locking the Earth into its frozen state. Life's endurance survival against the odds. It's hard to imagine life surviving in such extreme conditions. Yet life is remarkably resilient. During Snowball Earth, some organisms managed to cling to survival. They sought refuge in areas where conditions were less harsh, such as near hydrothermal vents, openings in the ocean floor that spew heat and nutrients. These vents provided a vital source of energy in an otherwise frozen world. Some organisms adapted to the extreme cold, evolving new strategies to cope with the harsh environment. The challenges of Snowball Earth also spurred evolutionary innovation. The extreme pressures of this period may have driven the development of more complex life forms, setting the stage for the diversification of life that followed. A new dawn thawing out and the road to recovery. The reign of Snowball Earth, though long and harsh, eventually came to an end. The very forces that triggered the freeze also played a role in its demise. Volcanic activity, while initially contributing to the cooling, ultimately became the planet's savior. Volcanoes continued to erupt beneath the ice, releasing massive amounts of carbon dioxide into the atmosphere. Over time, this buildup of greenhouse gases trapped enough heat to melt the ice, gradually thawing the planet. As the ice retreated, it exposed land and water, paving the way for life to flourish once again. The Snowball Earth event is a stark reminder of our planet's capacity for dramatic change. It also highlights the incredible resilience of life, capable of enduring even the most extreme conditions. Understanding this frozen chapter in Earth's history provides valuable insights into the complex interplay of geological forces, climate change, and the evolution of life itself.